Now, coming to the next lesson in this chapter, we are going to talk about the custom diagnostic GUI means graphic user interface via Canalyzer and Canoe. All right. Now, coming to the practical tools and diagnostic softwares of electrical vehicles, creating a custom diagnostic GUI via Canalyzer and Canoe is powerful and wide adopted in R&D approach. In the previous lesson, we spoke about the various types of tools like TechStream, VIDA, uh, VIDA, Xentry, etc., etc. Now, to prepare those tools, most probably Canalyzer and Cano are used, especially when working in electric vehicle subsystems like battery management system, VCU, onboard charger, thermal management system. Now, this custom GUI allows engineers to simulate, monitor, diagnose, and control ECU parameters via CAN, LIN, or Ethernet protocols via vector tools. Now, what is Cano and Canalyzer? Okay, we'll have a brief idea about what is Cano and Canalyzer because Cano and Canalyzer are huge topics. So discussing them in detail is huge task in itself. So, but I will give a brief mm, uh, overview. Now, first of all, coming to the Canalyzer, primarily a monitoring and analysis tool used for passive observation of network traffic and running test scripts. This sentence is important. Primarily a monitoring and analysis tool. Now, when it comes to Cano, it is a simulation, testing, diagnostics, and analysis platform for entire ECU networks. And it supports extensive hill, mill, and sill workflows. So, I hope all of you know what is meant by hill, mill, and sill. These are all simulation techniques used in the development of any software, like it may be ADAS software or engine software or transmission software. This hardware in loop, model in loop, and software in loop are the various steps involved in the software development. Now, talking about both tools support automotive protocols like CAN, LIN, FlexRay, and Ethernet, UDS, ISO 14229, KWP 2000, and DOIP. Now, talking about CCIP, XCP for measurement and calibration, J1939 for heavy electric vehicles. All right. So this is the standard which is governing the tool support for automotive protocols for heavy electric vehicles. Now, the question comes, why do you need a custom diagnostic GUI in EV development? Why can't there be a common standardized GUI in for every EV? All right. So what does this custom GUI and Cano or Canalyzer enable? First is it enables to create dashboards that mimic OEM diagnostic tools. Second is it reads and clears diagnostics from battery management systems, vehicle control unit, inverter, etc. And it also monitors live parameters like cell voltages, temperature, state of charge, and state of health. Next is it triggers service functions such as pre-charge contactor test, thermal control, run automated sequences like thermal runway test, and it also send UDS requests for fault injection and reconfiguration or diagnostics. This is especially helpful when the OEM tool is unavailable or proprietary. All right. So especially when OEM tool is immediately or there is no immediate proximity to the OEM tool, this Cano and these kind of tools are extremely handy. Now engineers need finer control over UDS services. And talking about the test automation is required for regression and or validation. Now talking about the key features of custom diagnostic GUI in Cano. All right. Now we'll see the key features. First is the most important feature is panel designer. Okay, in the panel designer, you can drag and drop GUI builder to design custom buttons, indicators, and graphs, etc. Second important feature is CAPL scripting. So event-driven C-like language to program diagnostic logic, handle button clicks, send UDS requests. Next is diagnostics DLL. access UDS service layer for DTCs, memory, etc. Now talking about XCP integration, the real-time calibration and monitoring. Next important feature, this is a very important feature, logging and visualization. This particular feature, it helps in plotting the graphs of voltages, temperatures and BMS status. Talking about the ECU simulation, it simulates BMS VCU response behavior if not available. And also when it comes to DO IP support for modern electric vehicles with Ethernet based diagnostics. And talking about the service routines, it calls for the specific UDS services like 0 by 31, which is nothing but a routine control. Now we will see a example workflow, BMS diagnostic GUI for via Canoe. How are we going to build a BMS diagnostic with the help of Canoe? Now, first step is set up a Canoe environment, import a DBC or ARXML file for BMS CAN signals. Okay, this is the first step, and configure the CAN channel via VN1690 or 5610. And next you enable the UDS diagnostic layer with the correct ODX and PDX file. So this is the first step. Now talking about the second step, design GUI using the panel designer. In the previous slide, I spoke about one important feature, panel designer, and it also add gauges like cell voltages, SOC, SOH, LEDs for faults, contactors, isolation status, and buttons for send diagnostic request, trigger pre-charge, start thermal system test, and also charts for voltage, temperature over time. Now but this is not exhaustive list by any means. Okay, these are all the things you can design or you can embed in the GUI using panel designer. Next, implement the CAPL logic. Okay, now how this logic is developed, well, that's beyond the scope, but as of now, just understand this logic must be implemented. Next is, once the logic is implemented, you run the diagnostic session example of UDS services typically used. Okay, these are the UDS services typically used: 0 by 10 for diagnostic session control, 0 by 22 read data by identifier, 0 by 19 read data DTC information, and 0 by 2E write data by identifier, and 0 by 31 routine control. Now this is something which I touched upon in the previous slide, and 0 by 11, that is ECU reset. Okay, so these are the step-by-step sessions that are used to in a typical development of interface. Next comes the testing and fault injection. The simulate fault codes by injecting errors from test scripts. So you are deliberately injecting a fault code, and also observe the DTC behavior and GUI updates. And next you run automatic test cases in the test module, and secure access for EVs with security access, and many ECUs require security access before certain diagnostics. All right, now this is the CAPL code that is implemented. All right, now for example, as a result of this implementation of the CAPL, these are the probable outputs. SOH is 72%, SOH is 98%, cell 1 voltage is 3.78 volt, cell 2 is 3.80 volt. So with this fault injection, you can find out that there is slight cell imbalance, and also DTC POA FA cell voltage deviation, and contactor status closed, and button is clear DTC clicked, and it sends 0 by 14. And also when it comes to use cases in EV diagnostics, there are plenty of use cases like BMS, cell balancing, SOC, SOH monitor, DTC read clear. And when it comes to VCU, drive mode selection, torque command monitoring. And when it comes to thermal, pump fan control, HVAC test. And when it comes to charger, start, stop, alternating current, DC charging, monitor power. And when it comes to inverter, motor speed, current feedback, and fault flags. So these are the various use cases in which the GUI can be designed with the help of Canoe and Canalyzer. All right. Now, naturally, what are the various tools used? licensed tools like Canoe with panel diagnostic options, Canalyzer with diagnostics add-on, CAPL editor for writing the CAPL code, vector hardware, which is an important tool when it comes to interface to EV CAN bus, and ODX and PDX files. Of course, this is optional. This is OEM supplied diagnostic definition. Okay, so to summarize, with the help of this customized diagnostic GUI via Canoe and Canalyzer, it gives a full control over UDS and CAN based diagnostics, and also visualization of EV subsystem parameters and fault injection and validation workflows. Last is customization for internal EV testing without relying on OEM tools. Thank you. Hope all of you got a clear-cut idea about the development of GUI with the help of Canoe and Canalyzer tools.